Hi, welcome to video 2 on the modulus argument form of complex numbers. In this video we'll be finding theta and the modulus of z in terms of x and y, where x is the real part and y is the imaginary part. For this video you need to know how to use Pythagoras' theorem and how to use trigonometry. So we'll start off with the graph we finished with in the last video. We know that the modulus of z cos theta and the modulus of z sin theta were equal to x and y. So I'll replace them with x and y in the graph. Now we know Pythagoras' theorem is a squared plus b squared equals c squared. So we can use this to find the modulus of z squared in terms of y and x. Then, if we take the square root of both sides, making sure it's the positive root as we're trying to find the length, we call it the modulus because we're trying to find the positive root. Now that's how we find the modulus of z, which is very simple. On the graph I'm going to add another point called w, which is simply z times by minus 1. If we worked out the modulus of w, it would be equal to z. You can try it for yourself if you like. Now say we were to find what theta is. Well, we could use our trig rules, knowing that tan of the angle equals opposite over adjacent. This being said, theta must equal inverse tan of y over x. That being said, let's do the same for phi. We just worked out to find the angle we do inverse tan of y over x. In the case of phi, inverse tan of minus y over minus x, which means phi equals inverse tan of y over x. Now this is weird because we know that phi does not equal theta, it's evident from the graph. We know that the values of tan repeat every 180 degrees or every pi radians. And from the graph we can tell that phi is simply theta plus pi, as there is a straight line which has radians of 1 pi. If I now flip these points in the RE axis, we get the similar dilemma where instead phi equals pi minus theta. However, as we know, this theta will be negative because of the direction around the graph from the RE axis it goes. We can therefore deduce the formula will also be phi equals pi plus theta. If we can deduce which side the point lies on the imaginary axis, whether it's on the left or the right side, we can determine what formula we must use to find the angle. In the case of it being on the blue half, we use the formula inverse tan of y over x. In the case it being in the red half, we use the formula inverse tan of y over x, then all this plus pi. Remember, y is the imaginary part and x is the real part. We call this finding the argument of a complex number, and on your calculator the function that does this is labelled arg of z. If you want to find where it is, I recommend googling your calculator make and where it is on there. Okay, well, thanks for watching. I put a few practice questions in the description with answers. You need to be familiar with finding theta and the modulus of z. In the next video I will derive Euler's form.